Hello, Matt Davis here with more homework quiz help. This one is from section 8.4. A recent sample of pregnant house cats produced the following gestation times and days, and we have all those given to us together with the sum of the x squareds. If we want a margin of error of 0.25 days or less, then determine the sample size required to compute a 90% confidence interval for the mean gestation time for all pregnant house cats. Use a point estimate for the population standard deviation from the sample and enter a whole number. All right, so first let's start off with changes so that we're giving help instead of answers. So we're going to take this margin of error right here and change it from 0.25 to 0.15 days. Instead of doing a 90% confidence, we're going to do 95. So we'll get rid of that one, change it to 95%. And then finally, we're going to change our data set a little bit too. So instead of this last value being 66.8, we're going to change it to 66.4. So that's going to change up the answer, but not the process. So let's go ahead and start looking at that process together. So first of all, what is it that they mainly want us to find? They want us to determine the sample size required to get a certain margin of error. So we're going to be doing an n equals type of formula. So now which formula depends on our setting. Our setting is confidence interval for the mean. So we want to get a sample size formula for when you're doing confidence intervals for the mean. When you go to look at that, which formula you use depends on what kind of standard deviation you have, and they're asking us to use a point estimate for the standard deviation from the sample. So a point estimate for the population standard deviation from the sample would be S. So let's go ahead and make a note of that real quick. So the point estimate that they're talking about is going to be the sample standard deviation, so that's going to be S. So we're going to need to find that, but more importantly, we're going to use that S when we do our computation of the sample size. So let's go ahead and move over to the formula sheet real quick and see which formula is appropriate if we're using the sample standard deviation S. All right, so since we're doing confidence intervals for the mean, we're going to be on this line right here. So we need our formula to come somewhere from there. This stuff down on the bottom is if you're doing proportion, but we're doing the mean. So we'll be on that line level at the chapter 8. So here's an n equals formula, and here's another n equals formula. We're trying to find sample size, so we're going to use one of those two. So which one? Well, we said we're going to use the point estimate S in our formula, and there it is right there. So this is the formula that we want to use, not the other one where you have a guess at sigma. Here we're using a point estimate from the sample, which is the S. So that's the formula we're going to use. So let's go back and write that down, and then we can start getting to work. All right, so the formula we're going to use on this one is n equals t star times S all over the margin of error they want, and all of that squared. So we now need to start assembling the pieces for that. One little piece of it we have already. They told us that they want us to use a margin of error of 0.15. The two things that we need are S and T star. So we'll start off with S, and finding that point estimate S was actually what the previous problem to this one asked you to do, so that'll help you with that one if you were stuck. But to go get that, we need to put that data in the calculator. So let's switch over to the calculator. And I actually already, to save a little bit of time, put the data in. So if you hit stat and then edit, that's where you'd enter the data into L1. That's all done. Once you finish that, you would next press stat again, and then hit the calc menu in the center, and we want one variable statistics, and we want to tell it that our data is in second L1. So when we press enter, we get a bunch of computations for that sample, and on the fourth line down, we get our point estimate for the population standard deviation, which is the sample standard deviation S. So that sample standard deviation S is 0.88810.319. We want that to 5 significant figures. That leading zero doesn't count, so we'll do 0.88810 for our 5 significant figures. The other thing you want to do while you're on the screen is check to see that your sum of x squareds match. That's the line right above S. And mine does not match, but that's because I've changed the data value. When you're doing this for your problem, it should match. If it doesn't, you have a typo. So make sure you check that. All right, so heading back and writing that S down, we came up with S is approximately 0.88810. And again, as far as significant figures go, we have 1, 2, 3, 4, 5. That last zero doesn't change the value of the number, but it makes sure people understand that we did write 5 significant figures like we're supposed to for a standard deviation. All right, so where are we? We know E, we know S. What we still need is T star. The value of T star is dependent on your confidence level. We're doing a 95% confidence level for this one. So let's go ahead and use that to find our value of T star. So we'll draw a bell-shaped curve. We'll put that confidence level of 95% in the middle, but we need to put it in decimal form, so 0.95. That leaves 5% left over, which we would cut in half and put 0.025 or 2.5% on each side. Make sure that you're always adding these three numbers up after you've labeled them on your picture, and make sure they add up to exactly 1. If they don't, then you may have forgot to cut the leftover area in half before you labeled the two tails, or you might have your decimals in the wrong spot. So any of those mistakes would mess up your value of T star, so make sure that you're double checking those. Our T star is going to be the one that has an area of 0.025 to its right. So we're going to be looking for T of 0.025 on our T table. When you go to the T table, you need a DF. DF is n minus 1. So what n do you use when you're doing this formula? You use the same value for the n. You use the n that came from the sample that produced the S for you. Sorry, I stumbled there a little bit. But we found this S right here using this sample. That sample had a size 11. So what t-score we should use is tied together with the S we used. The S came from a sample of size 11, so we're going to use a DF of 10 when we find the t-score that goes with that S. All right, so two key things. We want T of 0.025 with a DF of 10. So let's go ahead and head to our formula sheet and find that. So on the formula sheet, let's go down to the T table. We want T of 0.025. That's this column right here. So somewhere in this column is where we're going to get our value from. And we want the one that has a DF of 10. So the DF of 10 row is right there. So the intersection of the T of 0.025 column and the DF of 10 row is 2.228. So that is the T star that we're going to need. All right, so T star is 2.228. And that was the last piece that we needed to get to work on the formula. So this is scratch work. Let's start plugging in. We have our bracket. We have our T star, 2.228. We have the value of S, which was our point estimate from the sample, 0.88810. And all of that divided by the margin of error they want us to have at most, which was the 0.15. And then don't forget to square all of that. All right, almost there. Let's head to the calculator and see what that comes out to be. So open our parentheses. The formula has a bracket. You could use a bracket or you can use parentheses. It doesn't really make a difference on the calculator. So I put our T star times our sample standard deviation S, missed an 8 there, and then divided by the margin of error they're asking for, and I missed a division there, so let's get this cleaned up. Sorry, on this particular touch screen, it's easier to make typos than normal. So there's all the stuff inside the brackets. We close the parenthesis. Now we want to make sure we square all of that. So 174.00895. Let's go write that down. All right, so 174.00895. We need a whole number. You would think we would round that to 174 since we're so close to 174. But remember, when you're calculating sample size, you always round up, even if down is closer. We want to make sure we don't have a sample size that's too small, and so when we end up between two integers, we go with the bigger sample size. So what we would enter into active learning is this 175 right there. A few places that errors tend to happen on this. Sometimes people forget to put the square when they write it down. Sometimes they forget to put the square when they're on the calculator. You could mix up the formula, use the one with a z and a sigma, but because they're telling us to use the point estimate, which is an s value, we need to make sure we use the formula that has the s in it. When you do your DF is based on the sample size the S came from. So in this case, that was a sample size of 11 and a DF of 10. And then again, always making sure that you remember to round up instead of down when you get a decimal value for n and you're trying to figure out a sample size to get a certain margin of error. All right, there's a lot there. Hopefully somewhere in there you saw the spot that was giving you trouble. Good luck to you as you head back to the quiz.